We continue on to part 3. That was cut off at 15 minutes. So here we go. We were talking about the effector. So the effector is the organ that's going to do something about this. Whether it's the shivering, right, for you to bring your temperature up, that's those muscles, those shivering muscles are the ones that are going to get the job done. And then the response is that temperature going back up again. So remember that it's negative because if too high, make it low. If too low, make it higher. So here it's telling you the action negates or counteracts that stimulus, right? And then we return the variable to the original level. So great. We've gone through all those 5 steps, and these steps are the ones that you're always going to go through in all these different loops. So this is a really nice analogy that I really like, and it's the fish tank analogy, where you would have all of those steps. Let's say you had a tropical aquarium, and in there you had fish that had to be maintained at a certain temperature. But all of a sudden something's wrong, right? Stimulus. What's happening with the stimulus? Well, water temperature, too low, not good, right? It's below the set point. That's where it should have been. Set point is the term. So you have the sensor. What's the sensor? Well, it's a little thermometer sticking out of there, and it's checking the temperature of the water, and it's saying, oh yeah, indeed, this is too low. So then that signal needs to be passed on to some effector that can do something about it. So the signal, which is neurons again, right, is going to pass to an integrating center. So here, we're just going to call it this control box. So the brain, right, the control box. That's going to send a message via neuron, in this case, sending it over to the heater. So the heater is that effector, the one that can do something about that. So that's the target, right? The heater goes on, and it's showing it nice and red there. The heater goes on, the water temperature goes up, and then it's going to click itself off, right? We need something else to happen there for it to shut itself off. But that's the feedback loop. It was too low. You have to go through those steps to detecting it, doing something about it, until what? Until the stimulus is no longer there. So once that temperature went up, the stimulus is gone. Just written out for you, the response counteracts the stimulus. It shuts the response loop off, right? So the dotted line here is indicating that. We're shutting that initial stimulus off. The response happened, stimulus no longer there, we've shut it off. Then we're going to look at a different type of feedback mechanism, which is very unusual in the body, very unusual. It doesn't happen much at all, and that would be a positive feedback. A positive feedback would be a case in which the response reinforces the stimulus. So if cold, make it colder. If even colder, make it colder. And if it's colder, make it even colder yet. Right? So it sets that variable farther and farther from the set point. And the only thing that can shut that off is some outside factor from the body that's going to say, okay, we've solved this, stop. Because there's nothing in the body that works if cold, colder, 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 colder. If carbon dioxide levels are too high, make them higher, 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 higher. It's just it leads to death. So you need something that is going to shut it off externally. And there are always a few examples of that in the body. You can read about those. It's in your reading. So let's assume something like this. You have a person working outside on a hot, dry day, okay? And it's manual labor, and they're out like chopping some wood. It's really hot. And a whole lot of things are going to happen here. Happen. And at the very end, we're going to solve it. And we're going to solve it by adding water to those body fluids, and this person's going to be fine. But I didn't tell you what all these intermediate steps were, because I want you to think about that. What's going to happen from the point where there is and let's go back for you to see, there's a stimulus, right? There's going to be some sort of response, but what happened in between? So I'll just give it away. You can stop yourself there if you want to think about it before I continue talking. You can stop this video and then think about it a little bit. This is what's happening. Person's working outside, hot day. First thing that happens, sweat. right? They're going to lose body water by evaporation. So you're sweating, you're losing water. And the body fluids that are left behind are getting more concentrated because a lot of that salt is staying behind. So that concentration of salt is getting higher. So there's receptors that are going to tell that and stimulate your thirst. That's the only one that can fix it, right? When you're lacking water, the only thing that you can do, you can recycle for a little bit, but really the ultimate fix is that you've got to drink. So the person seeks out a faucet, goes, drinks water, and you fix the problem. But before that, you needed that sensor and you needed that thirstiness to be generated so that you would actually, your behavior is altered and you actually fix the problem. So think about the same person giving a speech in speech class. So this is classic because you have to give a speech and your mouth is dry and your palms are starting to get sweaty and you just wish you were not there. So you start out by giving the speech and here the heart rate goes back down. Right? So all the things that happened in between is what I want you to think about. And I'm not going to tell you. I'm going to let you think about that. Right? What would be going on? And this is the sympathetic kicking in, right? That's making you a little panicky there. What happens for it to eventually come back down again? I'm going to leave it at that. I want you to think about it. One last concept here in physiology is how we ask questions in physiology. You know, the why and the how. So if you are walking around the street and you go up to someone with a microphone and say, I'd like you to tell me, why do we see color? And what is the response going to be? Because some individuals going to say, well, we see it because it's pretty. We see it because evolutionarily poisons are bright red and we learn to stay away from those bright red poisons. That would be sort of why. But in physio, we're really thinking of how does it happen, right? So if someone says to you, why do we see color? Well, I just have to start explaining that we have this pigment in the eye, and when light hits that pigment, it's going to break it down, and we're going to be able to form an image. That's what we're thinking of when we're thinking of physiology, the how of how things happen. Not the why, which is more an evolutionary question, really. Why is it set up that way? Okay, so that was the last of sort of these major thoughts when we're thinking about A&P. And we're going to stop it there. Take care.